So we're on to question 6. This is the final of the concept and skills questions, the short questions for paper 1. It says a function f is defined by f of x equals 3 minus 2x all over x minus 5, where x is an element of the real numbers, x is not equal to 5. Find the inverse of x. Okay, so f to the power minus 1x is the inverse function of x, not to be confused, of course, with the derivative. Now, this is a very unusual thing that happens here. It happens, this is the only place it happens in the course that you use this particular technique. I'll go through it here. You start off with y equals 3 minus 2x all over x minus 5. Now, some books do this slightly differently. I'm going to do it like this. I'm going to start off with y being the subject of this equation, and I'm going to make x the subject. So I'm going to isolate x. So I'm going to multiply both sides by the x minus 5. So I'm going to expand the brackets. Yx minus 5y is equal to 3 minus 2x. And basically what my plan here is to get x on its own. So I'm going to rearrange. So basically I'm adding 2x to both sides. I'm adding 5y to both sides. All the time I'm trying to get x on its own. So I say x, I factorize out the x times y minus 2 equals 3 plus 5y. Divide both sides by the y plus 2, and you get x is equal to 3 plus 5y over y plus 2. Now, different people describe what happens next differently. So you can say, some people say you just switch the x with the y. So you get y is equal to 3 plus 5x all over x plus 2. Or you can say replace x with f inverse x and replace y with x. And you'll understand a little bit more on why this works now in a minute when we see the graph. Okay, so then you say f inverse x is equal to 3 plus 5x all over x plus 2. And for that little bit of work, you get 10 marks. So once you know the trick, it's actually a very straightforward question. But if you don't know it, you're never going to guess it. So you once you're here, you replace x with f inverse x and you place y with x. So then when you're subbing in for x, you're getting an answer. Your output then will be f inverse of that number. Okay, you'll understand, as I said now in a moment, when we see this graph, and it's the inverse function plotted. Okay, part B says the graph of G has a domain -1 is less than x is less than 8 and is linear from -1 -9 to 2 0, and then from 2 0 to 8 4. It is again linear, but it is obviously at a different angle, so there's two separate parts to this function. A sketch of y equals g of x is shown below. Write down the range of g. Now, this is actually an easy answer, so it may be confusing for students at the start, but when you actually look at it, it's relatively straightforward. It goes from a lowest point of -9 to a highest point of 4. So the domain are your input values. They go between -1 and 8. Your output values, your codomain, your range in this case is from -9 to +4, and that's for g of x. And that's 5 marks. So again, easy once you know how. F after g of 8, well, this is a compound function, a composite function. So what we do is we do what we're told here. It's f after g of 8. So we put and we figure out, well, when g is 8, when x is 8, what is g of 8? Well, we can see it from the graph. From the graph, when x is 8, when your input is 8, your output is 4. So g of 8 is 4. And then we're going to substitute x equals 4 into f of x, because it's f after g of 8. So we have our original function. We're putting in 4 for x, and we get, when we simplify it down, we get -5 over -1. We get an output value of 5. So f after g of 8 is equal to 5, and that was for 10 marks. So you might be surprised that sometimes students don't do better in questions like this when you see the answer. But you know, as often is the case, it's easy when you see the answer in front of you, not so much when you're in the exam trying to figure it out. Last but not least, it says sketch the graph of the equation y is equal to the inverse function of g of x. So g inverse x. It says show the coordinates of each point at which the graph meets or cuts the axis. So again, you could be thinking to yourself here, this is tricky, but you have enough information in here to do this question for sure. So in this case, with this graph and with this question, you're going to see now why that trick works, where you're switching the x and the y. Okay, are you replacing y with x inverse? And in this case here, this is what you can see there is the line y equals x, or the function y equals x. Basically, we can do an axial symmetry. Okay, a transformation by axial symmetry across that line y equals x, and we can figure out our corresponding points. And when we have them plotted here, well, we can focus in on the fact that this is the point 2, 0. So again, if that's my x and that's my y, what you'll find that when you get the plot the inverse function, but by getting the image of the original under axial symmetry through the line y equals x, what's happened is the x and the y coordinates have switched around. So if you think about this one here, like this would have obviously been my original y, and this would have been my original x. Okay, so you can see that for the point there with the axis. And you can see similarly for when we had minus, we would have had 0, -6 here. Down here we have 0, -6. And on the other side, we're going to have -6, 0. So again, the x and y, they've switched around compared to the next one. If you did the same down here, this would be the point -1, -9. And over here, this point would be -9, -1. We weren't asked for these ones, but last but not least, I just put in this one 8, 4, since we referred to them already. And up here would be the point 4, 8. And that is one kind of straightforward way of always drawing the image of an original function. When you're getting the graph of its inverse, all you need to do is switch the x and the y coordinates around, which is, of course, throw it back to where we started with finding the inverse function. And that was a final 5 marks for that. And again, straightforward when you know it. One of those questions that some students would have avoided because it wouldn't have been quite sure, but those who knew how to do it would have done very well in it. And you can see it's a relatively quick question to do as well.